Hello everyone, my name is Dr. KCH Apparao, working as an associate professor in a mechanical engineering department. Okay, we are discussing the question bank questions, critical thinking questions next to different numericals also. In this class, I would like to explain about the cross flow heat exchangers. What are the numericals which are related to cross flow heat exchanger? Next, how to find the it means rate of heat transfer in cross flow heat exchanger. We will see this one. We will see what is cross flow heat exchanger first of all. What is the difference between the counter flow heat exchanger and cross flow heat exchanger? We know that in cross flow heat exchanger, flow is perpendicular to each other. In this one also, heat transfer takes place between only two fluids. You know this one, but in parallel and counter, the flow direction is parallel to each other, but in cross flow, the flow direction is perpendicular to each other. Okay. So, if the heat exchanger other than the double pipe type is used, okay, the heat transfer is calculated by using the correlation factor. So, this is very important. If the heat exchanger other than the double pipe heat exchanger, it means the double pipe heat exchanger other than double pipe heat exchanger means we will use the cell and tube type heat exchangers. So in this cell and tube type, we will see the cross flow of fluids, hot and cold fluid. We will see. Okay, the heat transfer is calculated by using correlation factor. So this one is very important. That is represented by F. F is very important. So correlation factor is applied to LMTD, only for LMTD, for a counter flow double pipe arrangement. It means so cross flow for the cross flow heat exchanger also we use the same setup or same formula of counter flow heat exchanger, including the correction factor. Okay. So with the same hot and cold fluid temperatures, what are taken in the cross flow, it means counter fluid exchanger. Here also we take the same temperatures, all are same, except you have to add the F correction factor for the counter fluid exchanger. If you add this correction factor, it means you know that the rate of heat transfer formula for counter fluid exchanger, UA into delta T LM. Okay. So if you add this one, Q is equal to F into UA delta TLM. So this formula belongs to cross flow heat exchanger. Okay. So this F is nothing but a correction factor. So UA F into delta TLM. F is the correction factor. Here delta TLM formula, you know that one, delta T1 minus delta T2 by ln of delta T1 by delta T2. Same formula. Okay. But delta T1 is equal to, so delta T1 is equal to same set of hot fluid inlet minus cold fluid outlet. What was seen in counter fluid exchanger. So same formulas. Delta T2 is equal to hot fluid outlet minus cold fluid inlet. Okay. So same formulas, same setup. Okay, same arrangement what was taken counter fluid exchanger. Here also we'll take this one. So along that one you have to add the correction factor F. Okay. Okay, how to find F? We'll see that one also. Then if you know that F value, then you can use the formulas of counter fluid exchanger. Then you can solve the numericals. Rate of heat transfer in the cross flow also. Okay. The values of correction factor F according to the reference flow is plotted in the different areas. So 10 to 8 to just these are the figures which are given in the data book. By using those figures, you can find the or we can take the F value from the figures. Okay. So for several conditions also, here given here for several different types of heat exchangers. Okay, we'll see first of all. So this one already explained this one. This is very similar to counter flow heat exchanger except F, correction factor. If you add this correction factor to the formula of counter flow heat exchanger, then it will become the formula of cross flow heat exchanger. Okay, so Q is equal to UAF into delta TLM. Delta TLM is equal to similar to cross flow, so equal to cross flow heat exchanger. Hot fluid inlet minus cold fluid outlet, hot fluid outlet minus cold fluid inlet by, so delta T1 by delta T2, same formulas. Okay. We'll see the graph, first graph. The condition is correction factor plot for exchanger, heat exchanger with one shell pass, 2 or 4 or any multiple of tubes. It means so tubes are multiples, but one cell, multiple tubes. So how to take this diagram, this figure, then you can find out the correction factor F value with respect to P and R constants. We'll see what is P and what is R. So how to find out the P and R with the temperatures which are given in the numerical. Okay, you will see. So this is the first figure. This is the figure which is related to the setup, only one cell and multiple tubes. Okay, so this one is the 2 cells and multiple tubes, 4 or 8 or any multiple tubes and 2 cells, cell 1 and cell 2. So for this one, for this condition, so you have to choose this diagram. By using this diagram, you can find out the correction factor F value. So this one is the single pass cross fluid exchanger. Here both the fluids unmixed. Okay. So if both the fluids are unmixed condition, then you have to take this figure. Okay. So one fluid is mixed, another one is unmixed. Okay. For this one fluid is mixed, other one is unmixed. Then you have to take this figure. So based upon the condition, we have to take the figure. Based upon those figures, we can find out the correction factor value by using the R value and P value. How to find out R and P? What is the formulas of those? We'll see. Okay. So in this numerical, just we will see. Water at the rate of 68 kg per minute is heated from 35 to 75 degrees Celsius by an oil having this specific heat of the oil also given, temperature inlet and outlet also given, hot fluid inlet, hot fluid outlet, mass flow rate, specific heat. So all the values are given. So water means cold fluid. So MC, you know that CC also given, TC not also given, TCA also given. Okay. So MC, so that is nothing but 68 by 60 kg per minute into specific heat. So specific heat of the water. You know the specific heat of the water 4180 into cold fluid outlet 75 minus 35. So by using this one, you can find out the Q value. Okay, so that the value is equal to 189.5 kilowatts. Overall heat transfer coefficient also given. Next to another fluid is oil, hot fluid. Hot fluid entering temperature also given 110 degrees Celsius and leaves 75 degrees. Overall heat transfer is 320. Okay, so calculate the heat exchange area. Next to total heat transfer is determined. So this numerical is already solved in LMTD method. So we can find out the area. So for this one, you have to find out the delta TLM. So this is the what type of heat exchanger. This one is the counter flow heat exchanger. Okay. So counter flow heat exchanger. Then you have to take the formulas. Hot fluid inlet to cold fluid outlet. Hot fluid outlet to cold fluid inlet. Okay. So by using this one, you can find out the delta T LM is equal to 37.44. Okay. So you know that Q is equal formula UA into delta T LM. U already we solved that one. The value is equal to U 189. So this is 189.5. Overall heat transfer coefficient also given. So what is the value of that one? 320. So this is 320 into area into delta TLM. What is the area of delta TLM value? 37.44. So by using this formula, you can find out the area. So that area is nothing but this one. Okay. So this numerical is extended so that instead of the double pipe heat exchanger of example 1, it is desired to use shell and tube heat exchanger. Okay. Shell and tube heat exchanger. So one cell, multiple tubes. You have to take that formula figure also. So with the water making one shell pass and oil making the two tubes or 4 tubes or many tubes. So one cell, multiple tubes. Then based upon the condition, we have to take that figure for finding the correction factor. Okay. Calculate the area required for this heat exchanger, assuming the overall heat transfer coefficient remains at 320 degrees Celsius. Same setup. Okay. So then we have to add the correction factor F. Correction factor F. So we have to find out the F value. So for this one condition is one cell and multiple tubes. So by using the data book, you can take that to diagram. By using that diagram, you have to find out the F value. Okay. So for finding F value, you have to find out the R and P. So these are very important. By using this R and P, then you can find out the F value. Okay. So P. So what is P? P is equal to TC naught cold fluid outlet minus cold fluid inlet by same inlet temperature differences. Hot fluid inlet minus cold fluid inlet. Okay. So cold fluid temperature difference by inlet temperature differences. That is the P value. Similarly, R is the hot fluid temperature differences by cold fluid temperature differences. Hot fluid temperature differences. This is the cold fluid temperature differences. Okay. So by using this R and P, then you have to find out the F value by using that. What is the figure? The figure which is related to one cell and multiple tubes. You know that we'll see that that is the figure. This one cell and multiple tubes. Okay. So by using this one, you can see. So this is the P value. This is the R values. The R values. Okay. These are the graphs. By using this R values and P values, you can take that F value. Okay. So suppose R is equal to 3 and suppose P is equal to 0.4. Okay. So R is equal to 3, 0.4 or 0.25. So suppose this is the value. Okay, in this way, just like we have to find out the F value with the uses of by using the P and R values. Okay. Okay. So by using this P and R values, F is equal to 0.8. F is equal to 0. So by using this F value, you can find out the Q. So Q is equal to, you know that already rate of heat transfer, same rate of heat transfer. Q is equal to UA into F into delta TL. Okay. You know that F value, you know that U value, you know that F value, Q value also. Everything you know that. We had area you have to find out. Area is equal to Q by UA into U into F into delta TL. If you include the F, what is the area? We have to find out. That area is equal to 19.5 meters square. So this is the numerical which is related to cross flow. Okay. We'll see one more numerical which is related to cross flow. A heat exchanger like that that shows the here figure also given. Used to heat an oil in the tubes. Specific heat of the oil also given 1.9 kilojoule per kg Kelvin from 15 degrees Celsius to 85 degrees Celsius. Okay, heating an oil. So blowing across the outside of the tubes is the steam. Steam and oil. Okay, steam entering steam is THA is equal to 130 degrees Celsius and leaves at 110 degrees Celsius with the mass flow rate of O. So mass flow rate of the steam also given 5.2 kg per second. The overall heat transfer coefficient is equal to 275 watt per meter square degree Celsius. So for the steam, so this one specific heat of this steam also given. That one is 1.86 kilojoule per kg. Okay, so calculate the surface area of the heat exchanger. So here you have to find out the surface area of the heat exchanger. So first of all, you know that the condition. What is the condition? So one blowing across outside of the tubes enters the pipe. Based upon the figure, you can understand what is the condition, either 2 cell or 1 cell or multiple tubes. Okay. So first of all, we find out the Q value. Q is equal to MH and CH into hot fluid inlet minus hot fluid outlet is equal to MCCC into cold fluid outlet minus cold fluid inlet. So this is the formula. So steam mass flow rate of the steam has been given, and specific heat of the steam also given, and temperatures of the steam temperatures inlet and outlet, that is 130 and 110. So that one also given. So it means MH and CH and delta TH. So these values given. By using this one, you can find out the Q. Okay. So for the steam, all the mass flow rate value and the specific heat of the steam, inlet and outlet temperatures of the steam. So that is the hot fluid. So those values given. By using those values, you can find out the Q value. Then by using this Q, you know the formula for the cross flow use Q is equal to UA into F into delta TLM. Delta TLM you can find out by using the temperatures, because inlet outlet temperatures of hot fluid and cold fluid both are given. Okay, so then you know that value of Q and U value, overall heat transfer coefficient also given. Then you can find out first F factor. By using this F1, you have to find out the area. So identifying F value, so that is very important. Okay, so the figure, by using that figure by arrangement, so here figure is not given. So by using that figure, you can take F value by the help of data book. F is equal to, that value is given 0.97. If you know that F value, then you have to find out the, because by using the P and R values, you can find out the F value. Okay. Then you have to find out the delta TLM. If you know the delta TLM, then you can substitute all the values. Q is equal to UA F into delta TLM. Then area is equal to Q by U F into delta TLM. Okay, if you substitute all the values, Q value is equal to 193.000000 by overall heat transfer coefficient and F value and temperature difference values. Okay, then the area is equal to 10.82. So this is the numerical. So these are the textbooks for the reference I have given. You can refer more for solving the more numericals which are based upon the cross flow. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.